This is a video for Math 386 on logarithmic equations. Y equals log base a of x means a to the y, so I think about this like a loop. A to the y is the same as x. That's over here. Note, a is greater than 0, a cannot equal 1. F of x equals log base a of x is a logarithmic function with base a. Okay, now, some characteristics. The domain is 0 to infinity. Okay, the range is negative infinity to infinity. And when I look at this, I'm looking at this equivalent statement over here. So y can take on any value at once because that's the exponent for the base a. And then x is the result when you take a to the y power. So when you take a to a power, that'll never be negative and it'll never be 0. And so the domain ends up being 0 to infinity. The x-intercept here is 1, 0. The function f of x is equal to log base a of x is a logarithmic function with base a. Now, this function is 1-to-1 because it passes what's called the horizontal line test. And so let me kind of give you an idea. So here's y, here's x. Now, we have what's called a vertical asymptote at x equals 0. Because if we go back here, there is no value of y. So let me write that down. There is no value of y. That makes a to the y equal to 0. We can get close to 0, but we're not going to make 0. And so along the y-axis, I'm going to draw this dotted line. You might not be able to see that, so we'll do it in blue. Okay. So that's what's called a vertical asymptote. It's like a force field. And then I'm going to plot 1, 0 here. And then, well, let's come over here. So I'm going to go like this. I'm going to just give you a rough sketch. And then I'm going to come down like this. So now I drew, this is the case for a greater than 1. So let me write that down. F of x equals log base a of x, where a is bigger than 1. And notice how this function is increasing, right? And because it's increasing, notice how if I draw a horizontal line anywhere along this graph, it only touches or intersects the graph at most one time. So it passes the horizontal line test, and so therefore this function is what we call 1-to-1. And this is going to be the result. If log base a of x is equal to log base a of y, then x is equal to y. And if x equals y, then log base a of x is equal to log base a of y. Okay, from here, we're going to solve each logarithmic equation. So let's take a look at some examples here. So this is off the handout that I gave in class. All right. And with that, let's take a look at B. So what I have is log base 7 of 2x squared minus 5x plus 31 equals 2. So usually the rule of thumb is when you have a logarithmic equation, we want to convert it to an exponential equation. And when you have an exponential equation where you can't rewrite both sides with the same base, we want to convert it to a logarithmic equation because they're inverse processes, so to speak. So this is what we're going to have. 2x squared minus 5x plus 31 on the left side. On the right side, we get 7 squared. Now, 7 squared is 49, right? That's the right side. On the left side, we get 2x squared minus 5x plus 31. So I'm going to subtract 49 on both sides. And we get 2x squared minus 5x minus 18 equals 0. Now, let's factor. So I'm going to have 2x and x right here, right? And what are the factors of 18? So remember, 18 can equal 2 times 9, right? So can I have minus 9 here and plus 2 over here? And in fact, that's what it's going to be. So 2x minus 9 equals 0, or x plus 2 is 0. Now, if you have 2x minus 9 equals 0, I'm going to add 9 to both sides. So 2x equal 9, divide by 2, x is 9 halves, right? That's one of them. The other one is I'm going to have x plus 2 is 0. Subtract 2, and we're going to get x equal negative 2. So we get x equals 9 halves, or x equals negative 2. And that's how we do B. Let's take a look at C. Suppose I have log base x of 3x squared minus 5x equals 1. So I'm going to take x to the first is equal to 3x squared minus 5x. So 3x squared minus 5x is x to the first. So when you have a logarithmic equation, turn it into an exponential equation. So subtract x, and we get 3x squared minus 6x is 0. So I'm going to come over here. I'm going to factor out the 3x. And we get 3x times x minus 2 is 0. So 3x equals 0, or x minus 2 is 0. So x is 0, or x is 2. But I have a question. Now, let's note here. X is the base of this equation. And remember, x is positive, and x can't be 1 because x is a base. So we get to x this out and just stick to 2. And that's the correct answer for part C. Let's take a look at E. So on E, we have log base 2 of x minus 1 on the left side. On the right side, we get log base 2 of x squared minus x minus 16. Remember, the logarithm is a one-to-one function. And so on the next line, notice how they have the same base. So we could match the arguments. So in other words, x minus 1 is the same as x squared minus x minus 16. Okay? All right, now I'm going to subtract x, add 1. Subtract x, add 1. When I do, I get 0 equals x squared minus 2x minus 15. So if I factor, it looks like I'm going to get x minus 5 times x plus 3 is 0. So x minus 5 is 0, or x plus 3 is 0. So x is 5, or x is negative 3. And you guys have to pay real attention to this, because if I look at this answer here of x equal negative 3, and I replace x with negative 3, we got a problem. Because then I'm taking log of a negative number, which I cannot do, right? So this answer doesn't make any sense. And the correct answer here should be x equal 5, like so. And that's how we do E. That's a good question, okay? Let's take a look at F. So suppose I had log base 2 of x minus 3 divided by log base 2 of x squared minus 3 on the left side. On the right side, I get a half. So would you guys be okay if I cross multiply? So in other words, I'm going to take 2 log base 2 of x minus 3. Okay, that's this side. And on the other side, I get log base 2 of x squared minus 3. So log base 2 of x minus 3 to the second. So I can move that 2 in, okay? That's on the left side. On the right side, I get log base 2 of x squared minus 3. Now, notice how they have the same base. And so that implies x minus 3 squared is equal to x squared minus 3. So x squared minus 6x plus 9 is x squared minus 3. I hope that's okay. Can we see that the x squareds cancel? And I'm going to add 3 to both sides. And I'm going to come over here. And I'm going to write negative 6x plus 12 equals 0. So negative 6x equals negative 12. And so I can conclude that x equals 2. Now, here's the question. Does x equal 2 work? And if you plug that in for x, right? So you can plug it in the denominator or plug it in the numerator. And if you plug it in either one, that's not going to work. Okay? So this doesn't make any sense. And so the correct answer here should be no solution. Do we understand why? If I replace x with 2, I'm taking log of a negative number. And log of a negative number doesn't make any sense to me. That's the idea. And that's how we do F. That's a pretty good stopping point for this video. This is a video on solving logarithmic equations. And it looks like we did 4 examples for this. Okay. All right. Thank you.